so we have two forces of 495 newtons and 503 newtons act on a point. The resultant, so the result, is 970 newtons. Find the angle between the two forces. All right, so the first thing we want to do is figure out kind of how to draw something like this. So it's just convenient that we typically will draw one of the vectors like on the x-axis, again, just for convenience. And we will label this one the force 1 vector, which is the 495, all right? And then we'll label this one the force 2 at 503 newtons. And then finally our resultant, I tried to make that a straight line, would be force 3 at 970 newtons. And the reason we draw it like this is because we're going to end up making this look like a parallelogram. So you come on out there a little bit more. And then that way we can do some stuff with it, okay? Because I know some properties of parallelograms, kind of hard to say. And so using these properties, then I can label everything. So let's call this point here A. Let's call this B, this C, and then this D. All right, so labeling, I could say, well, then my line segment AB is 4 equals 2, I'm getting an equal sign there, 495, and then AC is 970, so that's that diagonal going straight through, and then a D, which is 503. And one of the main properties here, as I'm trying to look and change my ink color a little bit, is that the opposite sides of the parallelogram have the same length. So in other words, this length BC is also 503. Okay, so basically if I'm looking at triangle ABC, okay, so ABC, looking at that triangle, then I know 3 sides, and I want to be able to find the angle. So find the angle DAB, DAB, right? There you go. So in other words, that angle. I also know that adjacent angles of parallelograms are supplementary. Okay, so which is something very, very good to know. So what does supplementary mean? I don't know. You kind of sort of remember 180 minus the value of the angle. So if I use, let's get another, make this stand out, another color. If I use law of cosines, then I can set this up as 970 squared equals my other 2 sides, so 495 squared plus 503 squared minus 2 times those sides, 495, and then 503 cosine alpha. And of course I can go through all the steps and solve this for alpha, but because they're supplementary, I'll have to end up taking 180 minus that value. So I just threw all this stuff in a calculator and just kind of skip a whole bunch of steps. I know you love it when I do that, but moving all this over here, I got 442866. and then multiplying this stuff out here, I get negative 497,970 cosine alpha. All right, and then of course dividing, I got negative 0.889 cosine alpha. So I divided both sides by that negative 497,970. And then here I'm going to do that cosine inverse so I can solve this for my angle. So cosine inverse, all right? And need to get some area here. So let's go right back up here. And so when I solve this, I got the angle alpha. Did I say theta? I don't remember. Alpha equals 153 degrees by my calculator. And so then the angle between F1 and F2 would be 180 degrees because we said they're supplementary, which would be 27 degrees. Ta-da! That's it.